Welcome to another Achieving Science video. This video is going to cover limiting factors. First of all, we need to look at what affects photosynthesis. Well, photosynthesis is affected by a number of different factors. The first one being light. Plants need light in order to grow, but more importantly, they need light in order to carry out photosynthesis. Therefore, the more light there is, the faster the rate of photosynthesis becomes. Secondly, temperature is important. Plants prefer a temperature usually around about 30 degrees Celsius. Plants also require a good supply of water, as too little water can actually slow photosynthesis down. Another factor is the amount of carbon dioxide that is available in the air. As the more carbon dioxide there is, the faster the rate of reaction will become, and therefore the faster the growth will be. So now that we know what plants need for photosynthesis, let's have a look at some limiting factors. The definition of a limiting factor is, if a plant does not have enough of one of these things, then it is restricted and cannot perform any more photosynthesis than it already is doing. The thing that is restricting the plant from performing any more photosynthesis is called a limiting factor. So let's have a look at an example. If we look at the limiting factor of light, if there is not enough light, then the rate of photosynthesis will be affected. This can be shown via a graph. On our x-axis at the bottom, we can start off with light intensity, and on our y-axis we can show the rate of photosynthesis. Now if we plot a set of data, we'll end up with a curve to our graph, as shown in our video. So without enough light, a plant cannot photosynthesize very quickly, even if there is plenty of water and plenty of carbon dioxide. Now let's have a look at another graph. This one is for the limiting factor of carbon dioxide. Remembering, if there is not enough carbon dioxide, then the rate of photosynthesis will be affected. So again, we can plot a graph, this time though with carbon dioxide on our x-axis and the rate of photosynthesis on our y-axis. Now on a sunny day, the carbon dioxide is usually a limiting factor because plants receive enough light, but there is not enough carbon dioxide in the atmosphere to actually carry out any more photosynthesis. Finally, let's look at the limiting factor of temperature. Now, within photosynthesis, the whole process is controlled by enzymes. And therefore, if it's controlled by enzymes, as we know from previous topics, enzymes are affected by temperature. So if we look at this graph looks slightly different. We start off with temperature on the x-axis, rate of photosynthesis on the y-axis. And this time, it's not an upward curve. It's one that looks like a bell curve instead and goes back down. We can see that there is a peak at the top. This is the optimum temperature at which photosynthesis occurs. But above this temperature, around 40 degrees Celsius, these enzymes are denatured. So what happens as a light source moves away from an object, therefore? So if we have a plant and we move the light further away, as the distance that the lamp is moved away increases, of course the light that the plant receives will decrease. This is called light intensity. The inverse square law allows you to calculate how much light will actually fall on the plant as it's moved to different distances away from the lamp. Now the relationship is not one that is linear, and therefore is represented instead via an equation, where we have light intensity equals 1 divided by distance squared. Now where is all this important? Well, this is all important within greenhouses, because within greenhouses we grow plants, mainly for kind of food production. Now for food production, it's really important to know about limiting factors, as farmers and growers will do as much as they can to maximise as much crop, as much yield as they possibly can, and as quickly as possible. Now to ensure that happens, If we consider the limiting factors, all these farmers and gardeners would therefore need to ensure that the plants receive the maximum amount of light as possible. And this can mean them actually installing artificial lights to make sure the plants have light all the time, not just when the sun is out. They'll ensure that the temperature within the greenhouse is at its optimum, therefore around about 30 degrees Celsius, and therefore they will use heaters to ensure that this happens. Now these heaters that are used can also be paraffin heaters. By using a paraffin heater, these heaters will also supply carbon dioxide because they're completing the process of combustion, which releases carbon dioxide into the atmosphere, which is required by the plants. Overall, these conditions need to be managed to ensure the crops are still as profitable as possible, so not too much expense should be used on any of these factors.